All right, calculus 1 power rule proof speedrun using the definition of the derivative. So the definition of the derivative is limit as h goes to 0 of f of x plus h. So in our case, it's going to be x plus h to the n, and then we're subtracting x to the n because that's our f of x, and then this is all over h. And then we can simplify what's in there using the binomial theorem. So this becomes the summation from k equals 0 up to n of x to the n minus k, and then we have h to the k, and I forgot the n choose k here at the start, and then that's minus x to the n all over h. And then now we're going to take a look at three terms that are going to simplify in our binomial theorems. The first one is k equals 0. So then we have n choose 0. And if I have n objects, there's only one way to choose 0 of them. So n choose 0 is 1. And then I have x to the n minus 0. So this is x to the n. And then h to the 0 is 1. So we're not going to write that. But then at the end, we have minus x to the n. So those cancel. So we're not even going to write that term at all. Okay, the next term we're going to look at is n choose 1. If you have n objects, there's n ways to choose one of them. So n choose 1 is n. And then we have x to the n minus 1. And then h to the 1. Okay, and then now we're going to just write those as dot, 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 because we don't really care what those are yet right now. And then at the very end, we get n choose n. And if you have n objects, there's only one way to choose all of them. So n choose n is 1, and then we have x to the n minus n, which is 0. X to the 0 is 1, so we don't need to write that part. And then we get h to the n, all over h. Okay, now we're going to factor out an h out of the top. So we get h factored out, x to the n minus 1, and then that h goes away. And then the dot, 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 it's not going to matter because all those h are just going to decrease by 1 power. Powers of h by 1. And then we have, at the very end, the h to the now n minus 1, all over h. Okay, and then these h's cancel out, so then we have the limit plus a bunch of things, and they all have h's as coefficients. So that means they all vanish, including the one at the end here. Except we forgot the step over here with this n. I forgot to write this part. So it just equals this, and then now there's no h, so it's x to the n minus 1, done. What was the time?